All right, today we're going to look at combining functions. So this section at first looks like there's a ton of notation and things to get used to, and there's a little bit, but then you'll see after we do a few, it's really not complicated what we're doing overall. So in this box, the algebra of functions, it gives you all this information. Let f and g be functions with domains a and b, then the functions f plus g, f minus g, fg, and f divided by g are defined as follows. So I remember first looking at this and it looks like nonsense. So here are the four things we're really looking at, and we'll talk about those as we complete these problems. So for this first one, it says find all four of those things. Let me shrink this a little bit. Okay, so we're going to find each of those for these two functions. So we get f of g of x is x minus 3, and x squared is g of x. So it says find f plus g. So f plus g is just taking these two functions and adding them. So x minus 3 plus x squared is, I'm going to reverse the order so it's in a standard order, but that's done as it is. So it's x squared plus x minus 3. And that's it. So f minus g is just x minus 3 minus x squared. So if I rearrange those, that's what I get. So with that one, it's just x minus 3 minus x squared equals negative x squared plus x minus 3. So all we're doing is just combining these functions as they say. So f times g is just going to be x minus 3 times x squared. So if we simplify that, we get x cubed minus 3x squared. And our last one, f divided by g, that's the best one of all because it's a one-step problem. So x minus 3 divided by x squared. So that would be an example using two functions and working through each of those operations of combining. Okay, for composition of functions, again, you have this definition box, which is given two functions f and g. The composite function f of g, also called the composition of f and g, is defined by f of g of x equals f of g of x. So if you're not used to this, again, that seems like nonsense. But given two functions, all we're doing is plugging functions into functions. So I'll alternate with colors for this one. So let's do f of g of x. Okay, so what this means is that we're taking this function 4x plus 3 and we're going to replace x in f. So the f function, so I'm going to write this in red, is 2 times a variable plus 1. And instead of a variable that we're plugging in, we're plugging in all of g. So we have 4x plus 3. And then we simplify that. So we would get 8x plus 7 overall. So f of g of x is 8x plus 7. So if we look at the next one where it's g, so g of f of x is going to be taking g, which is 4x plus 3, so that would be 4 times whatever thing you're evaluating at, plus 3. So we're plugging in the function f into this one. So that's 2x plus 1. So then we just simplify that to get 8x plus 4 plus 3, 8x plus 7. Okay, so g of x. Well, that's plugging g into g. So we have g of x. And again, g is 4 times whatever we're evaluating at plus 3. And we're plugging g of x in for x. So this would be 4x plus 3. So we'd have 16x plus 12 plus 3. So 16x plus 12 plus 3 is plus 15. So for all of those questions, that's all we're doing. We're just taking the function itself and plugging it in for the variable. Okay, so the next topic would be domain of functions. So domain always comes back in almost every section we have to talk about it. So the domain of the composite functions is the intersection of their domains. So we'll do this example and hopefully clear that up. So for the f function, if you can look at that one, you can see that the only value excluded from the domain would be -1. So x can't be -1. And for the g function, which is root x, you have to have positive numbers or 0 in there. So this would be, the domain for that part would be x is greater than or equal to 0. Now, the question is, do those intersect? Well, here's -1 and here's 0 if I draw it on a number line. And at 0, I would have all numbers greater than or equal to 0, so I'd fill this in. And then -1 is just a value it can't be, so I can't graph it. Well, if x is greater than or equal to 0, then it has to be greater than -1. So -1 would be naturally excluded. So the domain for g and x would be x is greater than or equal to 0. Okay. Next little topic, this doesn't come up a whole lot, but there's a couple of questions that deal with it. It's in this section because we're adding functions. Graphically, this is a demonstration of what's happening. And this is the graph I pulled from the book. However, that looks confusing to me, so I think it's confusing to you as well. But basically, if I choose some point like A, so I put an A on the graph, and if I go up to the red line, so the red line there is f, so it's got some value here. And we'll say f of A is 1. Okay, so I'm just going to give this a value. F of A is 1. And then if we go up to the blue line, so I'm going to still go through that point, go up to the blue line. Okay, well, what is G of A? Well, according to the numbers I put on the scale, G of A is 2. Okay, well, the purple line represents f plus g of x. Well, then that means that this value on the purple line should be 1 plus 2. Okay, so if we add the distances of f of a and g of a, we get 3. So we go up to this line, should be around 3 based on the scale I drew. So 1 plus 2 is 3, and that would be an example of graphical addition. So all we're doing is adding the y coordinates to each other of each function.